Hello everyone, welcome back to my channel. In this video, we are going to talk about variables, and these are very fundamental concepts on the way we name things in Java. So, names are considered as one of the most fundamental parts of programming. And programmers should understand the syntactic rules in naming things inside the program, and as well as the semantic rules in using them. So if you have watched my previous video, you will be able to understand what I was talking about earlier about syntactic and semantic rules. So let's try to go ahead and open an Eclipse program, which is an IDE, and we'll try to put most of our contents in here. Okay, so I'm going to use Eclipse as my visual tool in order for you to see how things work, and so it would be easier for you to understand easily what I'm talking about when I will do it here in this Eclipse interface. So, so yeah. There are different types of names, and the most basic one is called identifiers. So let me just comment it out. So identifiers, they are the most basic names in Java. So when we talk about identifiers, these are names that you or the other programmers can actually name themselves. You can name it yourself. These spans from class names, variable names, and method names. So you have the option to make your own name. So the identifiers can be one or more characters as long as it is a letter, an underscore, or it could be digits after the letter or underscore. So let me just provide an example for you. So for example, here, since you are not allowed to put names outside the class. So for example, let me just quickly put, we will be later learning about data types. So you might be wondering what is this int stands for. Int is actually an integer, and we will try to make a name such as num. And then let's try to have it like num is equals to just num probably. Okay. So I think but we see there's an error here because you are not allowed to put names outside the class. So unless it's a package name, okay? So this regular variable name cannot be used outside the class. So we'll try to move it out. I mean, move it. Yes, remove it there and put it here. So let's try to put it here, and you can't see the error anymore. So that's good. Okay, so we have here different names. So num, it could be num like that. It could be just one letter like that. X. What else? Um, it could be um, underscore X here. This is acceptable. And let's have X, for example, X45. And this is actually correct. So again, this semicolon is a syntactic symbol, so we need to put that one to separate this line of code to the rest of the other codes. So yeah, that's it. So this is how you name things in Java. So by the way, it is important to note that the variable X, this one, is not equal to this one. So this X is not equal to this X. Well, actually, they are viewed as different entities. As long but if you try to let's try to have a value of this one. So here you can see it, they might be having the same data value, but they are actually different variable names. So you should be careful in naming things like this. So uppercase and lowercase mean two different things from a compiler standpoint. So violating the rules in naming identifiers will raise an error, such as the following. So what if you want a name that has actually compound names? So for example, you want to have a name of say for instance your cell phone number. So you want to say cell phone number. So you can see that there is an error here, and it says syntax error on token number. So you are not allowed to write this kind of stuff, this kind of naming system. So if you want two names like this, maybe I suggest if you really want two names, you put a space. Sorry, underscore. So so space is a syntax error in between characters, and as well as number before the letter. So for example, how about if you want like this 34? So this one is a syntax error because you're not allowed to write numbers before the character here. You're allowed to put the number after the letter. And yeah, there is a reason behind that. It's because it's evaluating this one directly, this 34. Okay, so this one is a syntax error. So you're not allowed to name numbers in Java, but you can put digits after a string of characters. Okay, so that's it. So there is also a so-called reserved word. So what we're seeing here is, so I'm putting it identifiers. Okay, identifiers, reserved words in Java, reserved words. Okay, and these reserved words are actually names as well, but you are not allowed to use it as identifiers. They are actually special names, special keywords in Java, so they are reserved words. You're not you are not allowed you are not allowed to be used as an identifier. Okay. Okay. Examples of reserved words are this: public, static, void, main. Okay. So public, static, void. So these are examples of, okay, we have here a syntax error, but yeah, these are examples of reserved words, and there are more examples of reserved words, and int as well is a reserved word, and there are many other reserved words in Java that you are not allowed to use as a name, as an identifier. So here in Eclipse, it's being color coded, so it's giving you a hint that they are not allowed to be used as an identifier. So yes, I will try to put like that. So examples, they are examples. Let's try to comment it out. Okay. So talking about style of naming things, it has been a tradition to name the classes with an uppercase letter at the beginning of the name. So you can see it here from the YouTubers class. I actually write it. The first character is actually a capital letter. So whereas the name of the variables and methods begin with a lowercase letter, so we can see here these are the names of variables and they begin in a lower case. So what about if you want to name classes using compound words? So like many names, compound names. Most programmers in Java actually combine them without the underscore connector. So if you can see here, I actually use an underscore, but most programmers don't use underscore. They actually use um, um, a style that has been retained from the first style. Okay, so for example, if you want to name to name, for example, if it's a class, okay, it's a class, so it is this is just an example of a style, naming style, I would say. And if it's a class like y minute, like minute bit code, minute bit code. So if you can see, it is actually a three-word words, but uh, actually I just tried to combine them all, but I tried to each word starts with an uppercase, so we can see the difference. Whereas you can as well, for example, if it's this is a name example of sorry example of a naming style. So this is for the class naming style for class. So we have also naming style for variables and methods. Say for example, if it's a compound word like the one that I did earlier. So we have x1 and then x. What else? Mm, say for example, peanut butter, things like that. So you can use style like this. Okay, so this style is called camel case style. So camel case, this style is called camel case style. Okay, so because it looks like a hump of a camel's back, but other programmers still use other styles too, such as the one that I did, like the underscore. Again, they are just styles, so computers, I mean machines, don't mind about it because they are just what humans actually made of, I mean think of. So yeah, you can make your own style, but I considered you incorporating this style in your own programming style because this one will become consistent. And lots of Java I mean built-in codes use this kind of style, so you won't be confused later on. So yeah, there are so many methods, built-in methods, and then expressions in Java that are already in the system when you install it. It's in the JDK, so you can in order for you not to be confused, then try to follow this kind of style, because developers, I mean designers of Java use this one. Okay, so it's much better to adapt to their own system. Okay, so there is also this thing called qualified names, which are compound names. separated by a period. So compound names. So we have also compound names. Compound names separated, okay, by a period. Okay, these are actually names that you have seen already. This is, I already commented out here. I'll try to delete the comment. So this is here, you can see this is an example. System dot out dot print line. So these are actually three names, but the names are actually being separated by a dot. So this is actually um, you may be surprised to know that this name is an address or a path to a name you want to access in a certain layers of containment. So actually, it has layers and layers of containment. So for example, system wants to access a name called out, and out wants to access a name called print line. So this is how this is how it's being accessed through the names. Okay, so this is why naming is very important. Okay, so programmers manipulate data in the name, which contains a reference. Okay, they contain reference to the memory location of the computer. Again, we only use names, and whatever data we put inside, such as numbers or strings, it is up to the machine to do its job to find its location in the memory of the computer. It's the programmer's job. The only thing that the programmers should mind is actually the name. Remember the name, okay? And this name is referred to as the variable, okay? So these are actually variables that I'm trying to show to you here, and they may contain data value, okay? You may be thinking that variables are names of data. Well, it's not quite right to say that, since variable is actually a name of a location in the memory that holds the data. So we try, if we want to define variable actually refers to the location, to the, I will say, memory location of the computer. Okay. Mm, and this actually may hold some data. Let me just quickly show you something else. Hold on. Okay, so you see here, this is a computer's memory, and we have here a variable x, for example, and imagine this is an integer type of variable, and it contains a 0. Okay, so it contains 0. So 0 actually is a data that is stored inside the computer's memory. Okay, so it contains 0. Yeah. So now, when you try to call x, this x here, when you try to, when the computer evaluate x, it looks for the address or the location of 0 in the computer's memory, so that it can use this data value for a certain kind of operation. Say, for example, add 1 to 0, increment 0, 1 at a time. So the computer can do that, okay, during runtime, okay? So you can think of the variable as a container here, the name of the container, or a box which you can use to store data for a later use. Now, the data inside may change during the execution of the program. Therefore, the variable can only refer directly to the container and indirectly to the data. Okay, so the variable refers to the container and indirectly referring to the data. Okay, I hope that is understandable. Do you know why it's like that? Because if it always refers to this value 0 here, that means that there's no way to change the data because it's always x is always equal to 0. At the start of the program, at the end of the program, it's always equal to 0. So if that is a semantic, I mean, a meaning of your program, if you want this kind of variable to be 0 at the end of the program, so it's okay because that's what you want. But if that's not what you want, it means that there is some kind of semantic error in your program, because actually computers is trying to update the data in the variable, because I mean, it depends on the code, but usually it's always updating, okay? So 0 might be at the end, from 0 might become 10. So it depends. So it starts from 0 and now the new value, it's actually 10. Okay? So that's it. Okay, so let's try to stop. Okay, welcome back. So let's try to go back to our class. Um, okay, so okay, so earlier we just use identifiers, and we'll try to initialize these variables. Say, for example, this one is equals to 1, x1 equals to 5, x1 is equals to 10. Okay, so this equal sign here is actually, we call this assignment statement. So if equals means assignment statement, okay? It's called assignment statement. So why do we need to assign data to a certain variable? Well, of course, we usually do that in a in terms of programming something. Assignment statement is used to put data into a variable. So let's try to make a given example here. So let's try to make x, to make it like more meaningful. Let's try to change x into something meaningful like rate. And then this one could be the principal. Okay, so let's try to remove this one. Okay, so rate could be, let's try to change rate into something 0.05, but we will change, okay, we'll try to change this one to double. Later we will be learning double, so we will try to we will not focus on this data type first. Let's try to focus on the data value. Okay, so 0.05, and we have the principal, let's say Let's say the principal is 25. Just an example, 25. So uh whatever value is in the right, this is whatever in the right is whatever value in the right is called an expression, which may compute data value or may refer to data itself. Okay, so this may compute a value or may refer to a data itself. So let's try to have an example on that complicated part. So this one, these are actually assignment statement that refers. Okay, so maybe I can move this one. I put it, I'll put them here. Okay, so that, okay, so these two are actually assignment statement that refers to the data itself. So you can see that they have like a direct data value, like rate is always 0.05. That's the data of the rate. The principal is that one. But there's also another assignment statement which actually compute data value and assign the value, the one that is already in that variable, to the new variable. Okay, so when the computer executes the program and see the expressions like this, okay, it evaluates the expression and assign the data value to the variable, which is the box that we were talking earlier. That means that the number 0.05 will be assigned to the rate, okay, and okay, 0.05 to the rate. So the question is, what if this 0.05 rate will, does rate always be 0.05 at the end of the execution? Probably not. Okay, so because it might not be the same. So say for example, let me just quickly do some kind of another interest. So I would say interest, okay, equals rate times, which is, this one is a multiplication operator, times the principal. Okay, so hold on. Why? Okay, say for example we have like this, in the program. So we have the rate, which is equal to 0.05, principal 25, and we have here an expression of interest rate times principal. Let's see if let's see the result. Okay, let's run this. The answer is 1.25. Okay, Suppose we have this kind of program that computes the interest of two data, say rate multiplied by the principal. So you can see here. Let's try to see. Let's try to see the output interest when this data value is multiplied to this one. So let's see. So it says 1.25. So that's it. Pretty much that's it. That's how you evaluate this kind of expression. Okay, before we end this class, I have a question for everyone. What is a variable? So there are 4 different ideas associated with variables in Java. And I would like you to think of these 4. Try to mention them all. Okay, please try to pause the video for a while and think of the correct answer. Okay, so here we are. A variable is a memory location. Okay, a variable is given a name. What else? A variable holds a data. What else? A variable has its own type. Okay, so these are actually the four essential ideas associated with variables. So I hope you learned something in this class, and I am hoping that I will see you again in my next video. Bye everyone, and enjoy programming.